feel free to raise your hand and ask some questions. With that, I'll hand it over.
All right, jump right in. So again, thank you guys. So I'm going to move around a bit. Again, I'm Michael Bulzomi. I'm Michael Bulzomi, the product manager for Greenheck Commercial Dampers. So it's control dampers, balancing, duct heaters, everything but industrial dampers. So our life safety is what we're talking about today. It's actually, anybody go to ASHRAE this year? No? Okay. This is the presentation I gave in the free sessions for AHR. It's the last time I'll say anything about Greenheck. I work for Greenheck. Everything you're going to learn today is about dampers, not about Greenheck. I'm not here to sell you. If you have questions, shoot them out. We have a hard stop at noon, so I'll do my best to be quick. I speak a lot. I'm on like 6 energy drinks right now. I'm from New York, so if I'm too fast, just flag me down. We're going to talk about life safety dampers. First, I'm going to tell you a little about myself. So I'm the product manager. I've been in the industry about 16, 17 years, doing nothing but sheet metal and mechanical products. I work for manufacturers reps half my career, manufacturers the other half. I've done custom air handlers, displacement diffusers, terminal units, grease duct, flue, you name it. I've worked for the manufacturer or sold it. I've been to every damper manufacturer's facility in North America except for 2 of the Mestec companies. I've sold or worked for every damper manufacturer except for Ruskin. So I know a little bit about dampers. I sit in about a half a dozen AMCA committees. I'm the chair of 2, founding member of 1. If you read ES Systems, AMCA in Motion, ASHRAE Journal, if anything comes from AMCA about dampers, comes across my desk first. More than likely I wrote it or worked on the committee that wrote it. So like I said, dampers are kind of my thing. We talk about HVAC, we talk about comfort, heating, and cooling. You guys maybe missize a register. Somebody's a little cold or drafty. You get a life safety damper wrong, you can kill somebody. That's why we treat it a little more importantly than other things. Before I go on, there's a lot of you guys in the room. Just really quickly, are we all mechanical engineers? Anybody doing commissioning? Okay. Scale of 1 to 10. 10 being you could give this presentation, 1 being today's your first day. Rough average in the room, somewhere down the middle, somewhere on the right. Anybody really new on life safety dampers? Okay, good. And I'm talking to you and you only today. There's a lot of learning objectives. Your only learning objective is to learn 1 thing about dampers today. I don't care what it is, but you're going to learn 1 thing. I'm going to ask each and every one of you what that 1 thing is. Now, we're going to go over what the different types of dampers are, their applications, their installation, the inspection requirements, the different differences between the dampers, some code stuff, talk about testing and inspection, different rating criteria through UL, and then talk about some improper installations. The fun part, I'll show you pictures. You spend all this time designing, doing models, using Revit, and then it gets to the real world. Doesn't always work out. First and foremost, we talk life safety dampers, Underwriters Laboratory, the preeminent testing lab, listing and application lab for life safety dampers, headquartered in Northbrook, Illinois. There are other laboratories. ETL, Intertac, Warnock, Hersey can list and rate dampers as well. We just choose as an industry to always go through UL. But if you actually read the building code, it doesn't say dampers must be UL rated and listed. It says dampers must be tested to the UL standard. So I can take a damper and go to Intertech, which is also ETL, and do the same testing I would with UL. Just the industry wouldn't really accept an ETL fire smoke damper. We see them on ceiling radiation dampers all the time. So if you're doing multifamily, low-rise wood truss, high-rise steel truss, you might see a Warnock, Hersey, an ETL, or an Intertech rated ceiling radiation damper. But for the most part, fire and smoke dampers, we talk about UL. You can go online to the Product IQ. Go to ul.com. You need a login, use your work or personal email. It's free. And then you can verify all the information on submittals, maximum sizes, velocities, ratings, everything's going to be in the UL directory. So that's a great way to get information. Why do we need life safety dampers? We say that necessity is the mother of invention. For life safety, it happens to be tragedy, right? So we build buildings differently because of the Great Chicago Fire. We exit buildings differently because of the Shirtwaist Triangle Factory fire in New York City. Our doors used to open inwards. The modern life safety code spawned because in 1980, I don't know, this is a different presentation. Sorry, we'll get to that. Why do we need them? For containment, we want to contain fire. We don't want it to spread. We want to compartmentalize buildings, right? So we're going to have rated walls, rated barriers to make sure that if there is an event smoke zones, different things, that fire doesn't leave the point of origin and do any more damage and endanger lives, as well as engineered smoke control systems, code required for certain buildings and certain occupancies. These are different types of life safety dampers. You have fire dampers, smoke dampers, combination fire smoke dampers, and ceiling radiation dampers. This corridor damper, that's a type of combination fire smoke damper. So it goes through the same testing as a fire smoke damper, but California Building Code requires in hospitals, in egress corridors for hospitals, you must have a 1 hour corridor rating to your fire smoke damper. So it undergoes additional testing to get that rating. Again, it's a California Building Code requirement. It is migrating. Little event in history, a couple of years ago, people decided to leave California en masse. That's engineers, building code officials, contractors, they take best practices with them. Remember, building codes are minimum standards. Nothing saying you can't design beyond the minimum standard. So some practices, some people are bringing the need for corridor dampers. So I've seen them in Arizona, Seattle, and Wyoming right now. And it could be in a neighborhood near you soon as well. So what's a fire damper? There's your definition from NFPA. We care about one thing with a fire damper. It's in there in red. We want to restrict the passage of flame. This is a fire rated wall. This partition is continuous. As soon as I penetrate it for an HVAC duct, I need to make up that hole. There's now a protection gap in that hole. So the rating has a fire resistance rating on the wall. I take a damper with a fire protection rating. I put it in there. So in the event of a fire, that damper closes. The continuity of that barrier is now maintained, right? That's all we care about, not smoke. Fire dampers are not leakage rated, not heat. There is no thermal properties to this blade. It's metal. Heat will pass right through it. Nothing else, just the passage of flame. I'll show you a couple dampers. Got your curtain fire damper on the left, true round in the center, and then a multi-blade fire damper. It looks very similar to a control damper. It's got a jack shaft, but it's got a fusible link and a helical spring. This spring, the link melts, that spring uncoils, spins that jack shaft, and the blade slam closed. Why do we need them? I just told you, containment and compartmentalization. We want to provide that effective fire resistive continuity of the barriers. And then we want to defend in place. So there's occupancies where people cannot egress. Surgical suites, isolation rooms, institutional, things of that nature. Trying to make sure there's enough time to put fires out or relocate people. And as I was saying earlier, that tragedy is the necessity of invention here. The MGM Grand Hotel fire in 1980, 86 people died, 85 people died, 700 injured. This was November 21st, 1980. 223 million in legal settlements in 1980 dollars, which is like, I don't know, carry the one, like $1 billion with inflation today, right? And actually, people went to jail. Why? The MGM Grand Fire Investigation Report from Clark County determined that the dampers in the main unit over the casino were bolted open by the contractor. They couldn't operate. I'm not saying all 85 people would have lived, but 82 of those 85 people died from smoke inhalation. They were in the towers. They were guests in the hotel. They were people's families there on vacation, right? Those contractors were charged with manslaughter. They knowingly tampered with a life safety device and it caused people to die. But this would have been caught if there was testing and inspecting requirements in the building code, and there were not. So Clark County adopted inspection and testing and maintenance requirements of dampers to prevent this from happening, and that's the whole purpose of testing our dampers. We'll go into testing in a little bit. So here we're just showing a protected partition versus an unprotected partition. Again, if this is a rated wall, it's going to protect the fire from going through, but if it has a giant hole in it, the fire is going to find that hole, and that's where it's going to want to go. So you have to protect that partition to prevent the fire from transferring from one side of the wall to the other. And fire dampers, man, the technology has not changed in over 100 years. It's a fusible link. So on the left is your curtain fire damper. Think of your blinds at home. You pull the drawstring on your blinds and they fall because of gravity. Same thing with this. That fusible link melts, that blade pack falls, gravity will pull it down. If the damper's in the wall in a vertical position, gravity pulls it down. I'm showing you a dynamic damper, and I'll get into the difference between dynamic and static. If there is airflow in the ductwork, you need an assist. Gravity is not enough to overcome velocity and pressure, so we put a spring on it. that spring actually pulls the damper down as well. I already explained to you on the multi-blade, I got a fusible link here, it melts, that damper slams shut. The difference between the two, nothing. They do the same thing. Code difference, if I'm the building code, I cannot tell the difference between these two dampers. They're both rated to UL 555. They both have an hourly protection rating. They're all both meet NFPA requirements. It's a cost issue. So what happens is those curtain fire dampers, anyone actually held in their hands a curtain fire damper, it could be a little flimsy, right? So think of a single panel, no problem. My contractor can install it, put in the ductwork. Not a lot of racking is going to happen. Not a lot of issues. When I have a really big opening in a mechanical room or a shaft wall or something, and I've got a 200 by 200 damper, I can't put like 20 of these panels in a row and just make them like 6 sections long, 4 sections high. That damper will fall to pieces. There's going to be a lot of blades and frames in the airstream, and it's going to be really difficult to pass the test. So as a function of passing the test, we switched to this multi-blade fire damper. Got some folks here that might remember, we used to do fire dampers with actuators on them. When they got really big, that was the only way we could pass the test. We've overcome those challenges and new design. We're able to take the actuators off and just do that. So the only time you're ever going to see a multi-blade fire damper, you're not specking. Your specs are most likely going to say something like curtain fire dampers with a type B enclosure. This is just going to be a function of a manufacturer's UL listing. So I do my test. I get a listing of a 100 by 100 for a curtain damper. I know I'm going to need something bigger, and I could pass 200 by 200 with this. So every damper in my submittal up to 100 by 100 is going to be a curtain damper, and then everything over that's going to be a multi-blade fire damper. Well, maybe my competitor was a little better in their testing, and they could do 150 by 150. So all their dampers up to 150 are going to be curtain style. The only thing that changes is the cost to the end user. These are more expensive than that, from simple material and labor costs. So the guy who has to provide more of these, his bid may be a little higher. You don't care about that. You don't care about meeting code, making sure the dampers operate. There's no difference. When it comes to pressure loss, they're negligible. When you have very big damper panels with lots of frames in the airstream, doesn't matter if you put a transition, what we call, I'll get into it in the next couple of slides. There are different transitions you can put on the damper to reduce the pressure loss. That only works on a single section. If I put 3 sections wide, 2 sections tall, I could put a round transition on it. It's not taking anything out of the airstream. Think if I had 3 of these together, 2 tall, all this middle stuff, it's all going to be in the airstream. Put whatever transition you want on it. It's never going to be 100% free area. It's negligible between a curtain fire damper and a multi-blade fire damper when they get very large. But these are our transition types. Type A is no transition. I've got a 12 by 12 duct penetration. I put a 12 by 12 damper. The top of this blade pack is in the airstream. It's eating up pressure drop. It's eating up free area, causing pressure drop, turbulence, and noise. To overcome that, I put this transition. We call that a hi-hat, a B type. My damper grows 2 inches in height. I still have a 12 by 12 effective duct opening, but now my damper is 12 by 14. But I have maybe, we'll say anywhere conservatively between 96 and 98% free area on a type B. I wanted 100% free area on a single section curtain damper. Because now when I have a multi-section, if it's 2 sections wide and I put this transition, the frame members on the inside of the dampers are still going to be in the airstream. So putting a transition on a multi-section damper does nothing for pressure loss. But this would be 100% free area on a single section. We most commonly see these round ones not being used for pressure loss, but because there's true round ductwork, and this is what we're choosing to put through there. There are other options. I already showed you. I've got a true round damper. I'm gonna give you a slide in a little bit here to show you the difference between a true round fire and fire smoke damper versus a square damper with a round transition. A lot of trade-offs in pressure drop and installation. So let's talk about some fire damper UL rating qualifications. Fire dampers undergo the test procedures found in UL 555 or UL 555. It's how its tiger earns its stripes. So I get a call from a contractor who says, hey, Michael, I need a fire damper. That's the equivalent of me calling my car salesman and saying, hey, Michael, I need a car. He's going to ask me 100 questions. I've narrowed it down to 4. There's 4 major things we need to know to get you in the right area of the damper you need. One, most important, and I'm going to go through each one of these in some slides. The system in which the damper is to be installed, is it considered static or dynamic? It's question number 1. Question number 2, what's the hourly rating requirement of the damper? Hour and a half or 3 hours? Question number 3, where am I putting this damper? Am I putting it in a wall, a floor? Where's it going? And then lastly, not as common, but still very important to ask, is there an obstruction behind the damper that I do not have access behind the damper to do service, testing, and maintenance? So I can have the damper mounted in the wall. I can have the damper mounted outside of the wall. I'll go into that in a minute in the slide and show you why that's important. So let's talk about static versus dynamic. Static systems, easiest way to remember this. A static system, the fan turns off in a fire emergency. There's a fire, a smoke alarm, building management system, fire alarm panel, something sends a signal to that and tells the main unit and the AC, turn off. There's no airflow going through my ductwork. That damper closes under still air. There's no velocity, there's no pressure. A damper can close pretty easily. If it's a dynamic system, the fans are on. There's 2 versions of dynamic systems. 1, intentional, an engineered smoke control system. I've specifically designed a series of fans and dampers to isolate and exhaust smoke during a fire event. That's the intentional. The unintentional dynamic system would be, anybody here designing multifamily? All right. There's a fire in a multifamily. What's telling that unit to turn off? Absolutely nothing. That's technically a dynamic situation. I'm going to have a hard stop at 12, so I'm going to just say this really quickly. I need a whole nother 3 hours to talk about ceiling radiation dampers. So if anybody wants to know about that, just we'll get you information. We can set something up online, but there's a lot of issues with dynamically rated ceiling radiation dampers right now in the industry. That's all. I'll leave it at that because I didn't bring my soapbox to this presentation. I just tell you, I've been working for about 3 years now to remove the dynamic listing out of the UL directory. It can no longer be built to spec and is actually useless. And it's causing so many issues to you designers because you don't quite understand the intricacies of UL designs and the architects don't do their job. Anybody here an architect? Should have asked that first. Architects don't do their job. They don't specify the floor ceiling assembly. They just give you a set of plans and then you go in and do your thing. And then they go, oh, by the way, here's the floor ceiling assembly. And it changes everything you've done on your damper. Leave it at that. Somebody pull me out. I'm going to keep going. All right. That's my static. So we understand that concept, static versus dynamic is very important. All right. So one thing that I dislike, but it is true, you can use a dynamic damper in a static system. You cannot use a static damper in a dynamic system. That does not mean every damper from today forward is now going to be dynamic. There's trade-off. It's a lot harder to pass tests dynamically. So I might have a single section maximum panel allowance static of 36 by 36. Dynamically, I've added 2,000 feet per minute, 4 inches static to close. It's a lot harder. Now my single panel maximum is 24 by 24. Well, if I do an oversized damper, static, I might have been able to do it in 2 panels. Dynamic, maybe I have to do it in 4. My cost just went up exponentially. So you're costing the owner potentially extra money he didn't need to spend. Also, if it's a really big damper, I may not have a listing for it. I can only get dynamic dampers up to a certain size. Vertical on a wall, on a scale of dynamic testing, pretty easy to pass. But horizontal in a ceiling, very difficult to pass dynamically in very large sections. So you can do a fire smoke damper, almost 4 panels wide, 2 panels tall, 8 panels big, really big damper vertically. Put that now in a dynamic situation and put it horizontally, and the listing becomes a lot less because it's a lot more difficult to pass that test. Jump into smoke dampers, very simple. There's your NFPA 105 definition. Smoke dampers do one thing: control the movement of smoke. Again, I got my true round steel V blade. Now I've got an airfoil aluminum smoke damper. I do not have aluminum fire dampers. Anybody want to care to guess why there's no such thing? I'll do one. Thank you. So that'll run into an issue where if you put in your duct spec, dampers and appurtenances must match duct construction, and you've got aluminum exhaust risers and you've got fire dampers in them. Well, guess what? You're going to get a stainless steel fire damper bid, because if I bid a steel and your duct spec said you need aluminum, steel is not equivalent to aluminum, but stainless steel is greater than aluminum from corrosion perspective. So that causes a lot. This is a pool, but I've done a university before where they put that in the spec. This is my funny story I get to tell. I went to SUNY Albany in upstate New York. In the dorm that I was in, I redid the entire dorm and I missed the duct spec. I said, match the duct construction. My engineer hung me out to dry and said, every single one of those dampers must be stainless steel, not the steel you quoted me. It would have been a 6-figure back charge to me. I went to the engineer and said, I went to this college. College kids do not shower. These toilets, they're not running constant humidity. It's not a pool. It's not a natatorium. It's not a spa. So I got him to let me off the hook. But if it's in the spec, you're responsible for it. So if it's in the spec and our guys see it here at CFM, they should pick that up. So we want to have those conversations ahead of time, just as an FYI. Why do we need smoke dampers? I already told you, smoke is the major killer. Fire destroys, but smoke kills. Smoke travels very far, very fast from the point of origin. So we need those smoke dampers to isolate and trap that smoke. Here's our rating qualifications for smoke dampers. Again, call my car salesman. Leakage class, right? We're trying to prevent the movement of smoke. Leakage is the most important. There's 2 options, class 1 or class 2. International Building Code for the United States requires a minimum class 2 leakage rating on all smoke combination fire smoke dampers. I do show class 3 with an asterisk. Canada, they allow class 3. Other countries don't follow international building code, allow class 3. So some manufacturers still build a class 3. We do not at Greenheck, but some do. Velocity and pressure now, because a smoke damper is controlling the movement of smoke, the movement of air, they're dynamic. They have an actuator, they're dynamic. So there's going to be a minimum velocity and pressure rating. The standard is 2,000 at 4 inches, 3,000 and 4,000, 6 and 8 are what we call extended velocity and pressure ratings. If you do not have high velocity ductwork on your job and you specify a damper with a closure velocity other than 2,000 feet per minute, you're not increasing the safety of your building. If your duct spec is all 1,500 feet per minute at 2 inches, and I put a damper that's rated to 4,000 feet at 8 inches, all I did was cost your customer money. The damper is no safer than it was before. It's never going to see that velocity and pressure. All you've done is, let's say that was a 24 by 24 damper. I have a UL listing to close a 24 by 24 damper with an 18-inch pound actuator at 250 degrees Fahrenheit, 2,000 feet per minute, 4 inches. Now we're going to do what we call the trash can spec. We want the biggest and baddest thing you guys offer. We're going to put class 1, 4,000 feet per minute, 8 inches, 350. All I did was change the actuator from an 18-inch pound actuator to a 175 inch pound actuator. Taking the cost of that actuator from, let's just say, $100 to $600 on every single damper for no reason whatsoever. You didn't increase the life safety of your building. So if you are specifying high velocity and pressure ratings on dampers, make sure it's for a good reason. I'm at an air handler. I have a lot of air coming through I have high velocity ductwork. There should be a reason why you're stressing it. Operational temperature. Smoke dampers are not fire rated. They have nothing to do with fire. Control the movement of smoke. This temperature is the rating on the actuator. 250 degrees or 350 degree maximum rating. 350 should only be used for engineered smoke control systems. If you put a 350 rated actuator for no reason other than it's greater than 250, I now went from an 18-inch pound actuator to maybe 175 or an 80-inch pound actuator, because the heat degradation of the output of the torque to pass at 350 changes the torque requirement of the damper, and then the actual construction of the actuator changes. Instead of using plastic gears, it has to use composite metal gears. So the cost of the actuator skyrockets. So again, you're not getting any additional safety benefits by over specifying a life safety damper. Now, if you're doing a data center, and they want a Miami-Dade hurricane-rated louver, and they want this, that's a different story, right? Well, that's called designing for redundancy and designing for resilience. We have a huge value of data inside that building. We're going to put the most expensive thing we can to protect that data. That's a different story. The people, on the other hand, they're not going to see any benefit. So a Miami-Dade rated louver can withstand a hurricane force wind versus the standard louver. So there is actual protection benefits. But for a damper, you're not getting any addition. Fail position. Are we designing smoke control systems in here? Okay, this is where it's very important. If you have the need for a damper to fail open so that ductwork can continue to be used for smoke control in the event of a loss of power, you got to put that note on the drawing somewhere or in the spec. If I ship a damper that's rated for fail closed, all the stars have to line up perfectly for me to be able to send a letter to somebody to say, you can flip the actuator over and use this for fail open. It rarely ever happens. And the biggest problem you're going to have is the label on the damper is wrong. You cannot relabel it. I cannot, you cannot, nobody can relabel a damper in the field except for UL. You'd have to call UL, pay them to do a field inspection, and then come out and relabel the damper. The point is, if you're doing smoke control or you have the need for fail open smoke dampers, label it on the drawing somewhere. We're going to always assume it's fail closed. Every damper we sell, we're going to assume fail closed. It's an industry standard. The fail open, again, is only used for smoke control. You can have a fail open fire smoke damper as well, and those are very special applications. So what is leakage class? Here are definitions from UL 555. That's class 1, the tightest and lowest leakage. That's 8 CFM per square foot. Class 2, the minimum building code requirement, 20 CFM per square foot, so 2.5 times more leakage, versus the class 3, which was 80 CFM per square foot. Let's throw all this out the window. What does this really mean? This room was 20 foot by 20 foot with a 10-foot, 8-foot ceiling, and had a 24 by 24 ducted smoke damper that was closed, and there was smoke pouring through that duct. If it was a class 3 leakage rated damper, this room would fill up with smoke in 10 minutes. Well, let me put this statement out there. Do not quote this. Do not go tell somebody that a class 1 damper gives you 100 minutes of protection. This is hypothetically speaking, so you understand the scale of difference in leakage between class 3, 2, and 1. Okay? Class 3, this room will fill up in 10 minutes. That's why the building code doesn't allow it. I'm pretty sure we can all get up in an orderly fashion and get out of this room and walk out of this building in 10 minutes. But if somebody's getting pushed, we don't want to do that. We have a minimum class 2 in the US, 40 minutes. It's enough time for all of us to get up, finish our sodas, pack our bags, walk out of the door, and we're fine. Most commercial buildings, couple flights of stairs, easy to get out. This class 1, there's no building code requirement to specify class 1. You're going to use them in hospitals. You're going to use them in institutional isolation rooms, places where people cannot leave and you're defending in place. This is the most amount of protection you're going to get out of a fire smoke damper. It's the lowest leakage rating. So the room will fill up with smoke in 100 minutes. So if it was in the hospital, I could finish watching Jeopardy, eat my pudding, and still get out of the hospital. Right? So what's the difference? So what is smoke control? There's passive smoke control and active smoke control. Passive smoke control, open and close. I'm just preventing the movement of smoke. I'm not isolating, it's not exhausting. I'm just saying there's a fire, there's smoke. Let me close this damper. Let me make sure nothing passes through this ductwork. That is compartmentation, containment. You're compartmentalizing the building into different zones. That falls under Chapter 7 of the building. Here's a typical diagram of an engineered smoke control system. No, that didn't work. Well, I'll just manually do it for you. So basically, you're going to have your supply air, supply hood. You're going to come in, maybe your return air. Fire is going to break out on the second floor. I'm going to close my dampers on the return side. So I'm going to positively pressurize the first and third floor. I'm going to close the supply side. I'm going to negatively pressurize on the third floor. And I'm going to exhaust my smoke out. This is showing a non-dedicated system, meaning that the fans are being used in everyday HVAC. That's important for code required testing purposes. That's a rudimentary smoke control system. So again, one of those dampers had a fail open. If that was a fail closed damper and it wasn't clearly labeled on the plans, that's going to be a problem sometime down in the field during installation. We basically want to avoid doing anything to a damper once it's shipped from my factory. So the UL rule, UL states once a damper leaves the manufacturer's facility, they cannot guarantee the workmanship that's been done to the damper. Doesn't matter if I do it. Once it leaves my factory, anything, this is going to scare a lot of you, but it's okay what I'm about to say. Anything you do to a damper after it leaves the manufacturer's facility voids the UL listing. Anything. However, the industry accepts certain things. Changing an actuator. I'm doing my regular maintenance. Actuator's dead. I can change it. I inform the building owner. I document the change. I contact the authority having jurisdiction. Maybe he wants to see a cycle procedure to make sure the damper still works. The industry accepts that. Everybody goes about their business. According to UL, that just voided the UL listing of the damper. Somebody's come in and changed things on the damper. It falls under field procedure and it's acceptable. Sometimes a building owner will turn around and say, I want UL to come back and recertify this damper. It's completely on the building owner to do that. We accept in the industry changing actuators because imagine if we didn't, how difficult that would be. The UL's perspective is something was done to that damper. UL listing is void. So like we allow under the, we always put this sentence as a damper manufacturer. We'll write a letter and at the very end of it, we'll say, subject to the approval or at the discretion of the authority having jurisdiction. The AHJ has the final call. Doesn't matter what the building code says, what the intent, that AHJ accepts it, he accepts it, or she accepts it, or they deny it, they deny it. Doesn't matter sometimes how logical your argument is. Whatever they decide is whatever they decide. I know a few of you probably have a couple of those building inspectors that you know I'm talking about. So again, I'll get into it a little bit more down the line of what was done to some of these dampers that voided UL listing. There's certain things you can do that are industry accepted and don't cause any issue. Let's talk about fire smoke dampers real quick. Fire smoke damper, before a fire smoke damper, if you had a shaft wall or a barrier that required both smoke protection and fire protection, you put a fire damper in the opening and a smoke damper behind it. We came up with a single device that meets the needs and requirements of both. It's tested to both standards. At the end of the day, it's a fire damper. I can use it for smoke control. The minute it reaches the limit switch temperature of that damper, so if it's a single limit of 250 degrees, the damper's dead. It's part of the wall. I cannot reopen it for smoke control. Once it reaches the fire damper portion of it, it's done. It is now a fire damper, no longer a smoke. Still, in certain cases, be used for smoke control. If it hasn't, if there's a dual temperature switch on it, or if it hasn't reached its limit switch, you can still operate it like a smoke damper. Once it reaches its high temperature, it's done. Again, it meets the requirements of both 555, 555S. It's dynamically rated, and it always ships with a factory mounted actuator. That's pretty important. That changed many years ago. We had some recent supply chain shortages because of events that happened around the world. And actuators were greatly affected. Honeywell, Belimo, they were struggling to get components overseas. There's a lot of shortages. And as a damper manufacturer, I got a lot of requests. Can you just ship all the dampers without actuators? And we'll put the actuators on when they come in? And I'll do that. If you were ever told by a contractor or a manufacturer that they will do that, ask them to put that in writing. They won't, because they're not allowed to. They're not allowed to ship a damper without a factory mounted actuator. One particular manufacturer is doing it. That's why I bring it up. They didn't want to lose the job. I get it. But what could potentially happen is that damper has a UL label on it. The building inspector should be doing their job and should be looking at the submittal and should know if the actuator matches what's on the submittal versus what was actually provided. How many building inspectors are checking that on every single damper, every single job? They're not. So what actually happened was the contractor put non-fire smoke rated actuators on all the fire smoke dampers because they're cheaper. They're not rated properly. The whole reason why we factory mount them to prevent that from happening. So fire smoke damper UL rating qualifications, just take everything I told you about fire dampers everything I told you about smoke dampers, I'm not gonna go over it again, but that's where it's at. It's two dampers in one, so it has to meet the requirements of both. It gets rating for each of those requirements. Now, I don't know if I specifically went over, I skipped the in wall and out of wall. Got a picture here real quick. This is what we call an out of wall fire smoke damper. The damper normally is tested with the blades in the closed position within the plane of the wall. So I have an opening in the wall, the damper closed is somewhere in that wall. So picture like a red dotted line, down the center line of the damper, it's in the wall. Well, I'm in a shaft, or maybe I'm in the corridor of residences and I cannot get access to the residences behind it. Maybe there's an obstruction. I could do my service through the face of a grill. I test the damper to where the damper is outside of the partition, a specified distance. So for Greenheck, wood stud, 7.5 inches, steel stud, 8.5 inches. For another manufacturer, it's 5 inches. For another manufacturer, it's 3 inches. Every manufacturer is different. What this does is I can pull the grill. Let's say I'm walking down the corridor. I got smoke purge grills on a high rise. Can't get to the residence because it's high-end apartments and I'm not going to knock on somebody's door to test the damper. I'm just going to pull the grill off in the corridor, do everything I need to do, put the grill back on, and I'm good. Same thing out of the shaft wall, with the same concept. I touched on corridor dampers. Well, I went too many slides over. Again, required by the California Building Code. They go through that additional test. It's a 1 hour heated airflow test to get that rating. Again, that corridor use is the egress. Egress is the evacuation of that building. Actuators, ceiling radiation damper. One job for a radiation damper. Limit radiant heat transfer in a floor ceiling or roof ceiling assembly. So let's call this a membrane penetration. Right above us, I got a T-bar ceiling. Let's pretend the ceiling is fire rated. I got displacement diffusers everywhere, no ceiling, no overhead. But let's say I had a plaque diffuser right there. Well, everything is fire rated, but there's an opening for the neck of that plaque diffuser. If I don't protect that opening, I'm going to get this funnel effect. There's a fire in this room and a diffuser with a neck opening above it that was unprotected. The heat is going to find that hole. Everything else is rated. The heat will find that hole. It'll funnel, and it could affect the structural capabilities of the floor above it. It's concrete, it can crack and explode. If it's steel, it can warp and bend or collapse. The leading killer of firefighters, an injury of firefighters falling from buildings. We don't. So we protect those openings with ceiling radiation dampers. This is one of the takeaways everyone's going to walk away with today. Fire dampers and ceiling radiation dampers are not interchangeable. They are not the same thing. You cannot, in any instance where you need a ceiling radiation damper or a membrane penetration, whether it's a gypsum ceiling in a multifamily wood truss, in a lay-in ceiling, in a high-rise, you cannot substitute a horizontal fire damper where a ceiling radiation damper is going to go. There's never been a fire damper tested and approved for the same application as a ceiling damper. It doesn't exist. If I go to the installation manual of a fire damper, there is no installation for a ceiling membrane. There's no installation for a wood truss assembly. Therefore, I cannot install it in that. It happens every day. It happens every day. Again, for my multifamily designers, say I put a furnace in a closet, sheetrock it in. I duct up through the ceiling into my trusses, and then I dropped all my registers, right? That penetration needs to be protected, and then all my ceiling penetrations on the register. Those register penetrations, 10x8, 12x6, it's all standard stuff. It's this penetration coming off the unit. I got an 1800 CFM unit feeding an apartment, 2 bedroom, blah, blah, blah. Maybe I have a 18 by 18 discharge on that furnace. Maybe I have a 20 by 20 discharge. Well, what happens commonly is somebody will take what I'll call a B-class manufacturer. So I'm going to be really mean right now. I have A-class manufacturers: Greenheck, Ruskin, Naylor, Potoff, United Enertech. And I have B-class manufacturers: Air Technologies, Lloyd's, Royal Metals. They're not damper manufacturers. They're sheet metal manufacturers who got into the damper business because it's complementary to theirs. There's damper manufacturers and then sheet metal manufacturers that also sell radiation. The sheet metal guys that sell radiation dampers don't know a thing about the building code. Don't know a thing about where dampers go. They know how to sell sheet metal fittings. They've got a bunch of guys buying sheet metal fittings who said, hey, I need ceiling radiation dampers. Can you get those for me too? And they got one listing and they sell them all over the country. Anybody who knows ceiling radiation dampers know how intricate and tricky UL listings are and approvals are for whose dampers are approved for use in what assembly. What we commonly have is contractor will go, hey, I can't get a damper big enough, a ceiling radiation damper big enough. Lloyd's doesn't have one big enough for this application. Don't worry about it. Just put a fire damper there. They both have the word damper in their name. They both made of metal. They both have something to do with fire. They both have a fusible link. They're both UL rated. They are two different animals that do two completely different things. So never allow that in a submittal. Never allow that in a walkthrough. Anybody ever asks you, can I use a horizontal fire damper in place of a ceiling radiation damper? No, there is never an acceptable answer where a fire damper can be used in place of a ceiling damper. One takeaway everyone's going to walk away with today, right? Go ahead. Yes. And we would never have a through penetration in, let's say, a low-rise multifamily wood truss without building a proper shaft. No. So, yeah, exactly the same. So the terminating on the grill, it's all ceiling radiation damper through penetration. The damper itself has a different construction feature. So on the grill mount, the frame is 5/8 deep. So it sits flush with the sheetrock. On the ducted, we put a little duct drop on it. So the contractor's got some meat to attach his ductwork. So it drops 2.5 inches below the ceiling. Codes and standards relevant. Oh man, I never thought that. Codes and standards. International Building Code, NFPA, AMCA, underwritten by. We went through a bunch of this stuff already. You all know the I codes are just a combination of all the regional codes put together. We care about the International Building Code for the design of the buildings. We reference mechanical fire code as well, but everything we really need to know about dampers is in the IPC. Chapter 7 is our main thing, fire and smoke protection features. This is going to be your containment dampers. Chapter 7 is open and closed dampers. All right, I'll tell you what the standards that they must be listed and labeled to. And this is the important part when we talk radiation dampers. Again, I'll say it again. The building code cannot say dampers must be UL listed. You're not allowed to do that in the building code. It creates a competition problem. I forgot what that word is. Building code only says dampers must be listed and labeled to the applicable UL standard. That comes into play with radiation dampers every day. Talk about that later or offline if we have to. Different types of barriers found in the IBC. I've got this little chart. I have a PDF of this. You'll all get a copy of it. I'll send it to CFM. Basically, it's a little cheat sheet. It tells you the wall type, what section of the code it's referenced from, and the type of damper that's required. If you see fire damper, smoke damper, again, it goes back to before the inception of combination fire smoke dampers. You had 2 dampers, so if you see that, that would be a combination fire smoke. Now, me not being a degreed engineer, I don't like giving design advice. I'll give design commentary. Here's what I've seen done in the past. If you say, what is the code requirement in Denver for this type of building, this type of occupancy, this, I'll say, I'm sorry, you're the degreed engineer. Too much liability for me to see the work. But I would say, I believe this is the best damper for the application. Check with the building code or check with the authority. Damper test requirements. I'm not going to go through all this. For those of you doing commissioning, actually, no, this is where it states here in the building code. It's chapter 7, 7173.1. Fire damper shall comply with the requirements of UL 555. Again, nothing says fire dampers shall be UL labeled and listed. So we go back to those ceiling dampers, test standards. There's 2 different test standards for ceiling dampers. If I'm in a drop ceiling, T-bar ceiling, it's what we call, wherever there used to be a hinged door type damper. Anyone familiar with what a hinged door type damper is? No? Okay, cool. I got a picture of it. Right. This is my ASHRAE presentation, sorry. This is a different version. Hinge door type damper contractor, take a metal plate, an insulated box, put a fusible link on it. That plate would be attached to the top of the box. And that link melted, the plate would just fall closed. There's your old school ceiling radiation damper. Damper industry came along and said, no, we can build those better. We want to do a comparison test. Wherever you allow a hinge door type damper, we want a UL 555C damper allowance. That's why you can put in a lay-in ceiling price diffuser with a nailer damper and a thermal blanket you bought from Ferguson, or I can buy a fire rated package diffuser from Price Industries and pop that in there, and that's got a thermal blanket, a ceiling radiation damper, and a diffuser, all the same thing. Those are UL 555C applications. It doesn't matter whose damper goes where, as long as it's a 555C rated damper, meets the requirements. UL 263 is our wood truss dampers. So in a low-rise multifamily wood truss assembly, your architect is supposed to give you a design number. Going to sound something like L521. Anybody here ever heard of that? It's the most prolifically specified floor ceiling assembly. 12 minutes. I think I can do this. L521 is a proprietary number owned by a damper manufacturer. That damper manufacturer was very smart. They cornered the industry. They did groundbreaking testing and got the first listing for combustible wood truss with an HVAC penetration. And then they went to UL and said, we own this. Anybody else wants to do this, they have to test and list to their own number. We're going to market the heck out of L521. We're going to go to every architect and drill it into their brain, specify L521. The next company that wanted to go get the same listing was told the manufacturer that got the listing for L521 does not give you permission to use L521, you're going to be granted L550. And then the next one was told the same thing. And the next one was told the same thing. According to UL's perspective, if you look up the floor ceiling assembly, L521, for those two gentlemen who know what it is, there's one manufacturer listed, Pottorf. They also own CNS Air Products. It's their secondary brand. Those are the only two manufacturers listed. If I call UL and say, my architect specified L521. I want to put Greenheck's damper in it. They'll say Greenheck's damper has not been tested and approved to L521. So Greenheck went and tested M508. It is identical to L521. But UL will not allow a manufacturer to use the word identical in marketing because the dampers are different. Because they're a for-profit lab who doesn't want to get sued by Pottorf because they've been threatened multiple times. They will not allow damper manufacturers to make the logical argument. Everything is the same. The testing procedure, the rating, the sheetrock, the trusses, the this, the that. If you put it side by side, everything's the same except for the damper. But because the nature of UL 263, that test, it's a full assembly fire resistance test. Everything in the room for L521 is the rating. It's not the damper. The damper has a UL label on it. The damper on its own has no rating. The sheetrock, the trusses, the insulation, the bats, the blankets, the resilient channels, the damper, the boot, everything together is the rating because of 263. That's UL's perspective. Intertech does not believe the same thing. Intertech will test a damper and approve it for L521, L550, because they will make the logical argument the same construction. The damper passed in one, it's going to pass in all. Because Pottorf does not own L521 in the ETL directory, they own it in the UL directory. I'm going to run out of time to doing this. Do we kind of understand that a little bit? And when you're approving submittals for multifamily, do you consider that? Do you look at the UL listing and go to let's say it's a P554. You pull the P554 listing and look at the damper manufacturers and then go back to CFM and say, sorry, only Ruskin is approved for this. I can't accept that. Okay. So there are alternative methods. I can give you documentation to support why another damper should be allowed in that, but you have to make the judgment call to approve it. The authority having jurisdiction has to also. So there's some liability there. But again, that's the UL perspective. So we can talk offline about that a little more if you've got questions. Just all that to say, If you are approving multifamily wood truss projects, pull the UL listings the architect gave you. And if you don't have the architect's information of what the assemblies are, you can't approve the damper because you don't know what's allowed. The worst thing that happens all the time. Buildings are being built. Everything's being ordered. The architect finally gives you the assembly number. You go to the UL director and guess what? It's never been tested and approved for use with a damper. What do you do then? The building official has to now make a judgment call. Will he accept this? If things are being built already, that's a big problem. If they're not, you just literally cross it out and change the number from L521 to the damper manufacturer you provided, and it's just a clerical. All right, fire resistance ratings. Again, we're in the international building code. This is where we determine what are the rating requirements of my fire dampers and fire smoke dampers. Real simple. If my barrier is less than 3 hour fire resistance rated, I use an hour and a half damper. If my barrier is 3 hours or greater, I use a 3 hour damper. So there are 2 hour assemblies, there are 1 hour assemblies, there are 4 hour assemblies. So if I have a 2 hour assembly, I use an hour and a half damper, a 4 hour assembly. Talked about static versus dynamic, periodic testing and requirements inspection. So again, International Fire Code references NFPA 80 and 105. And the International Building Code says the same thing in section 7, ducting or transfer openings. And 80 and 105 basically say, like I mentioned earlier, I install a damper, I commission it, I test it. I check if it's got visual inspection capabilities, remote inspection capabilities, or position indication capabilities. That's all the same thing. I verify that that is working and accurate during my commissioning. Then 1 year later, I test the damper again. And then in commercial buildings, every 4 years, I test my damper. In hospitals, it's every 6 years, I test my damper. And we do this for 2 reasons. One, we commission it, test it a year later, and then 4 years. And damper has been tested 3 times in a period of 5 to 6 years. In the first 5 years of a new building, probably this, how many times do you go into a building and new walls are put up, new offices are made? Anybody here work for IT? IT guys, what do they love to do? Run cables through dampers. Look, a giant opening in the wall, let's put my cable. So whenever you have these new offices, it's good to check first year, and then 4 years later, because that's where the most changes are going to happen. And then every couple of years, you're coming in, you're checking to make sure the dampers are still working. There's other indicators that dampers don't work. Somebody's always constantly complaining that they're hot or cold. I bet you the damper's closed. They can play with that thermostat all they want. Usually a good indicator. So again, we reference the 80 and 105. There's operational testing. And then there's the periodic testing. So periodic testing is the operational is the commissioning. Damper, I install it, damper works, cool, I'm good. Conducted after the system's in balance, smoke damper, after the installation of the damper is complete for a fire damper. And these are the little pictures of things we find. I have to point that out. So I've got a block. So here's my actuator sticking out of the wall. That's not correct. Here's a pipe running through a fire damper. Everybody here, they're just as bad as IT guys. I've got a Coke or Dr. Pepper can. Somebody forgot their tube of caulk. And why does this happen? Anybody know why this happens? You open it, more than likely this is a construction issue. I got a bunch of contractors that got no power to the damper. They're hot. They got air, but they got no power to the damper. So what do? They slip the jack shaft, prop something in it. They get their air to their site. Then they're done working and they finish everything they do. They forgot they did this to the damper. Well, if I didn't have the commissioning, the 1 year and then every 4 year testing, I'd never catch this. And 85 people would die in the MGM Grand Hotel fire every year. But because we have this, this is supposed to catch any of these deficiencies that happen during construction or remodel or tenant movement. Minutes. How many guys? Perfect audience. Ever design a job with heat pumps? You schedule every one of those heat pumps, right? Okay. You ever do linear diffusers? You put those on the schedule, right? By show of hands, how many of you put dampers on a schedule? I thought so. Every single one of you are my arch enemy. Why wouldn't you schedule dampers? What's the big reason why anybody in here wouldn't schedule dampers? I'll give them to you if you're shy. You don't want to make a mistake and miss one, and now you're liable for it, right? Guess what? Whether you schedule it or not, if you miss it, you're still responsible. If the building inspector says, hey, there was supposed to be a damper here, and the contractor goes, it's not on the plan, not his fault. It's not there. It's not my fault. It's your fault. Whether you scheduled it or not, if it needs to be there, it's still your fault. So that's number one. Number two, it takes a lot of time, and it's laborious, right? So what I'm hearing is, if it was really easy for you to push a button and do everything you needed to schedule dampers, every single one of you using Revit would schedule dampers, right? Maybe 50%, maybe one of you would. One of you, come on. I would like to see it more. It makes everybody's life a lot easier. I get it. It's a big job. You might have to add an extra page to your plans to schedule dampers. But if you're doing riser diagrams or you're doing something like that, you're doing everybody a huge service. And Revit, it's pretty simple to generate that schedule if you have the right tools. That was a slick lead in for something I'm going to do in the next 6 months. Anyway, pressure drop, very important. Do you guys care about pressure drop of dampers? How many of you have a cheat sheet on your desk that says dampers under 24 by 24, take a 1/10 of an inch pressure drop, and dampers over this size, take that? That is the worst thing in the world. And if you can do, you are completely inaccurate. Completely inaccurate. Depends on how I'm mounting the damper has an exponential change in the pressure drop. So if I just look at purely the size, first of all, this is the most common, ducted in, ducted out. 5 diameters of straight duct, up downstream, upstream, 6 upstream. How many jobs actually have that 0? But that's how we test it. I've got a plenum mount, and then I've got a ducted inlets like a grill mount, right? If you're looking at this line, and this is your application, what's your difference? It's 5.3, the lowest pressure drop. The same velocity for 5.5, it's exponentially higher. Now, if I'm taking just some random piece of paper that somebody gave me, it could have a serious impact on the fan energy being consumed. Maybe you're oversizing equipment now. Certainly having problems with your dampers. Maybe you're trying to figure out why you're not getting the airflow you're needing. Could possibly be that. There's no real good information out there. When you compare the AMCA figures, if we look at the AMCA pressure drop figures, and it's got a 12 by 12, 24 by 24, 36 by 36. All those AMCA pressure drop figures are the nutritional facts on the back of a cereal. So I can look at all my cereals in a row and go, I'm a health conscious guy. I like to eat low carb. Which has the lowest carb? I'm going to pick that one. All that is doing, I can put every damper manufacturer side by side with AMCA rating and go, they have the lowest pressure drop on a 24 by 24. I want that one. It's really misleading. I'm going to give you, we ran out of time. It was the biggest fact. No, I'm going to give it to you anyway. I got a hard stop. Let's be quick. Damper manufacturers build the golden sample for AMCA testing. I'm going to design my AMCA sizes to be the lowest pressure drop. Everything outside of that is not tested and rated. So my 12 by 12 has a rated pressure drop of, let's say, 0.05 inches water column. My 13 by 13 could be a 0.2 of an inch pressure drop because I use blade stops. I use different configuration. If you really want to be sure of the pressure drop, ask the manufacturer to provide you in the submittal with the as-built or every single damper pressure drop and look at them and compare them. Now, all of you are going, I've never even considered that, right? You be quite from Oregon with the pressure drop. I ran a comparison. He was working with the University of Texas. They would not allow my damper manufacturer in the spec because their spec said 36 by 36 must have a maximum pressure drop of 0.08 inches at 2,000 feet per minute. So I bought that manufacturer's 36 by 36, took my 36 by 36, put it on a chamber, tested it. Theirs was lower than mine. I said, great. I'm going to take a 38 by 39, test theirs versus mine. Their pressure drop double. They use what's called a blade stop. So Greenheck and other manufacturers can use variable blade width technology where they have more than one width blade. So if I've got a really tall damper, I can use combinations of 5, 6, and 7-inch blades to make up that space. But some manufacturers have one size blade, 5 inches. So if they have to make up the rest of that space, they just put a blank plate. It's not a rated size. They're only looking at the AMCA sizes. Nobody cares about the pressure drop of that damper. We all care about that. This is something that we're going to be working through AMCA, doing a little more exposure to the designing, great design world, and exposing the true pressure droplet damper. So I just wanted to get you thinking about that. Time here, that was a big one. Installation. I don't approve installation. So if you get a call from a contractor and he says, hey, I got a picture, send it to the manufacturer, I need this installation approved, I'm not an authority having jurisdiction. I can't approve anything. All I can do is point out deficiencies and point out things that look correct. If I physically am not there to inspect the damper, I don't make comments on pictures. Most pictures from contractors are usually the good side of the damper, never the bad side. But certain things we always want to tell them to make sure, like we're not responsible for the building of the partition, but my contractor goes up there, we tell them make sure the openings are square, right? Dampers must be square, plumb, straight. Want to make sure that they're framed appropriately. And if there's a problem with the framing, and the contractor says, hey, studs are supposed to run floor to ceiling. 12-inch, my GC made a mistake, or 12-foot, he ordered 10-foot. He wants to splice them. Is that okay? So I don't know, ask the authority having jurisdiction. If he approves that barrier construction, then you can install my damper. I don't approve barrier construction. So typical installation details I'll go through again. Nobody's pulling me out. Where's my? I'm going to keep talking until you tell me to go home. Oh, I have 40 minutes to get to my next appointment, so I'm only going to speak for 5 more. Just a couple of notes here. Annular space, expansion gap, expansion clearance. Fire dampers, fire smoke dampers are made of metal. Metal gets hot, it expands. So if I had a 12 by 12 opening and I took a 12 by 12 damper and I pushed it in that opening, once it gets hot, fire gets close to it, the damper is going to expand. Those blades are not going to operate properly. They're going to start to warp and expand. So we have this expansion gap. It's a little bit different for every manufacturer, but generally it's somewhere in the magnitude of 1/8 of an inch per linear foot in width, plus 1/8 of an inch per linear foot in height. Minimum 1/4 inch, maximum plus 2 or 3 inches. So what does that all mean? If I have a 12 by 12 damper, 1 linear foot, 1/8 of an inch, 1/8 of an inch, 1/4 inch minimum. I can make that opening a minimum 12 1/4 by 12 1/4, and then a maximum of 14 1/4 by 14 1/4. Greenheck has plus 2 inch maximum opening. So if I had a 24 by 24 damper, you do the math, I can actually make that opening 28 and change or whatever it comes out to. We don't want to do that, but you can. Sometimes guys cut holes the wrong size. Sometimes they got to move the damper around. You got a little bit of freedom to do that, but you have to cover those openings with retaining angles. If you buy them from me as a manufacturer, I make 2 size angles. One with an 1.5 inch leg, one with a 2 inch leg. If you made I had a contractor make his openings as big as they could be. He needed a 5 inch leg on his angle. Well, they ordered angles from me thinking that they were going to cover the opening. I said, no, my angle's 1.5 inch by 1.5 inch. You have to fabricate that yourself. So again, that expansion clearance is important to the function of the damper. The one thing that can never happen is putting anything in there. So if an inspector says, hey, I know there's a gap around this damper where smoke can penetrate or flame can penetrate, put fire wool, put rock wool, put intumescent. No, do not ever put anything in the gap. It's in my installation instructions. It avoids the UL listing of the damper. Maximum, the sleeve can extend out of the opening. If I provide the access door on a fire damper, 16 inches. On a combination fire smoke damper on the actuator side, 16 inches. On the non-actuator or non-access door side, 6 inches maximum. So let's say I have a 4 inch partition, 6 plus 4 plus 16, 26 inch sleeve maximum. What's the minimum the sleeve can extend out of the partition? UL and NFPA does not regulate that. They don't care. The minimum is whatever is needed for a proper UL qualified installation. So on a fire damper, I might ship a standard 16-inch sleeve. That's a lot of sleeve that you don't need for a fire damper. I could probably get away with an 8-inch sleeve. If I have contractors with really big hands, they might hate me. I like to say 10-inch sleeves on fire dampers. It's important to know, you guys probably shouldn't be specifying sleeve length, but you might be saying factory or field provided sleeves. We'll work with the contractors on best practice. Lastly, already got my big takeaway, right? Was the big ceiling dampers and fire dampers. Are they the same thing? All right, good. We're all paying attention. Installation on a smoke damper different than a fire dampers, right? So smoke dampers, since they're not fire rated and they're not structurally required to stay within the partition like a fire damper is, I can install a smoke damper up to 2 feet outside the partition. There's no additional testing for an out of wall smoke damper. It's the preferred installation. Contractor will cut a hole in the duct, slip his smoke damper in, seal around it, call it a day. If you are specifying sleeves and angles on smoke dampers, take that out of your spec. It's not a requirement. The installation, it's not a UL requirement. You're costing a lot of money for no reason, and it's a much more difficult installation. They are not required. Access doors, 3-sided installation. So our retaining angles are typically 4-sided. They could be on one side of the damper or both. There's size limitations on where you can use them. But every once in a while, I'm in a jam. My damper is tight to the floor, tight to the wall, tight to the ceiling, and I don't have the room to install one leg of my angle. You have to have a UL approved installation to do a 3-sided angle installation. So if you go working with a company that isn't Greenheck, contractor has an issue, hey, my damper is tight to the wall. I can only get the angle on 3 sides. Just request a copy of the UL approved 3-sided angle installation and make sure they have that installation. That's all you got to do. True rounds, I touched on it real quick. Anybody have a problem with approving a true round damper versus a square with a round transition? If you saw that on a submittal, would that throw you for a loop? Have you seen the true rounds? I get at some engineers that are petrified of true round dampers for some reason. Okay. There should be no reason. They're more cost effective, easier to install, and could be up to 85% lower pressure drop than compared to a multi-blade with the square round transition. The framing is the same for a square damper and a round damper. The hole in the sheetrock is the same. It's square. I cut this template, this retaining plate takes the place of a retaining angle. We have an embossed template on it, a square template that matches the requirements of UL. Cut a square hole. You put the cinch plate on the damper. You put that over the framing, or you put the sheetrock up. The plate goes over the sheetrock. That goes into the wood stud framing. You're done. Nothing was different. It's the same installation. There are limitations. I can only get up to 24 inches round. So if I have a larger than a 24-inch round, I got to go to my square with a round transition. But I'm saving money, 20 to 40% more cost effective, cheaper, and up to 85% lower pressure drop. It's a win-win, no brainer. I don't see why anybody ever would want to do that. So I'm done. That was it. That was the last one. So yeah, we're out of time. I know there's like a million questions. You can ask them all to CFM and I will answer them all for you. Now, if anybody is interested in sealing radiation dampers and learn a little more, get with you. We can set something up online. I can come back anytime. It's a very important topic. If you're designing multifamily, I strongly encourage you to reach out and learn more about sealing dampers. It's only going to get worse. If you think it's bad now, it's only going to get worse. So I got for you guys. Thank you so much. Apologize for running a little bit over, but hopefully we learned